Sediment is a naturally occurring material that is broken down by processes of weathering and erosion, and is subsequently transported by the action of wind, water, or ice, and/or by the force of gravity acting on the particles. For example, silt falls out of suspension via sedimentation and forms soil. Sediments are most often transported by water, wind and glaciers. Beach sands and river channel deposits are examples of fluvial transport and deposition, though sediment also often settles out of slow-moving or standing water in lakes and oceans. Desert sand dunes and loess are examples of aeolian transport and deposition. Glacial moraine deposits and till are ice-transported sediments. Classification: sediment can be classified based on its grain size and/or its composition. Grain size. Sediment size is measured on a log-base-2 scale, called the Phi scale, which classifies particles by size from colloid to boulder. Composition. Composition of sediment can be measured in terms of parent rock lithology, mineral composition, chemical makeup. This leads to an ambiguity in which clay can be used as both a size range and a composition. Sediment transport. Sediment is transported based on the strength of the flow that carries it and its own size, volume, density, and shape. Stronger flows will increase the lift and drag on the particle, causing it to rise, while larger or denser particles will be more likely to fall through the flow. Fluvial processes, rivers, streams, and overland flow, particle motion. Rivers and streams carry sediment in their flows. This sediment can be in a variety of locations within the flow, depending on the balance between the upwards velocity on the particle, and the settling velocity of the particle. These relationships are shown in the following table for the Rouse number, which is a ratio of sediment fall velocity to upwards velocity. Where is the fall velocity, is the von Kr-Man constant, is the shear velocity. If the upwards velocity approximately equal to the settling velocity, sediment will be transported downstream entirely as suspended load. If the upwards velocity is much less than the settling velocity, but still high enough for the sediment to move, it will move along the bed as bed load by rolling, sliding, and saltating. If the upwards velocity is higher than the settling velocity, the sediment will be transported high in the flow as wash load. As there are generally a range of different particle sizes in the flow, it is common for material of different sizes to move through all areas of the flow for given stream conditions. Fluvial bead forms. Sediment motion can create self-organized structures such as ripples, dunes, anti-dunes on the river or stream bed. These bed forms are often preserved in sedimentary rocks and can be used to estimate the direction and magnitude of the flow that deposited the sediment. Surface runoff. Overland flow can erode soil particles and transport them downslope. The erosion associated with overland flow may occur through different methods depending on meteorological and flow conditions. If the initial impact of rain droplets dislodges soil, the phenomenon is called rain splash erosion. If overland flow is directly responsible for sediment entrainment but does not form gullies, it is called sheet erosion. If the flow and the substrate permit channelization, gullies may form. This is termed gully erosion. Key fluvial depositional environments. The major fluvial environments for deposition of sediments include deltas, point bars, alluvial fans, braided rivers, oxbow lakes, levees, waterfalls, aeolian processes, wind. Wind results in the transportation of fine sediment and the formation of sand dune fields and soils from airborne dust. Glacial processes. Glaciers carry a wide range of sediment sizes, and deposit it in moraines. Mass balance. The overall balance between sediment in transport and sediment being deposited on the bed is given by the Kshner equation. This expression states that the rate of increase in bed elevation due to deposition is proportional to the amount of sediment that falls out of the flow. This equation is important in that changes in the power of the flow changes the ability of the flow to carry sediment, and this is reflected in patterns of erosion and deposition observed throughout a stream. This can be localized, and simply due to small obstacles, examples are scour holes behind boulders, where flow accelerates, and deposition on the inside of meander bends. Erosion and deposition can also be regional. Erosion can occur due to dam removal and base level fall. Deposition can occur due to dam emplacement that causes the river to pool and deposit its entire load, or due to a base level rise. Shores and shallow seas, oceans and lakes accumulate sediment over time. The sediment could consist of terrigenous material, which originates on land, but may be deposited in either terrestrial, marine, or lacustrine environments, or of sediments originating in the body of water. Terrigenous material is often supplied by nearby rivers and streams or reworked marine sediment. In the mid-ocean, living organisms are primarily responsible for the sediment accumulation, their shells sinking to the ocean floor upon death. Deposited sediments are the source of sedimentary rocks, which can contain fossils of the inhabitants of the body of water that were, upon death, covered by accumulating sediment. Lakebed sediments that have not solidified into rock can be used to determine past climatic conditions. Key marine depositional environments. The major areas for deposition of sediments in the marine environment include littoral sands, the continental shelf, the shelf margin, the shelf slope, beds of estuaries with the resultant deposits called bay mud. One other depositional environment which is a mixture of fluvial and marine is the turbidite system, which is a major source of sediment to the deep sedimentary and abyssal basins as well as the deep oceanic trenches. Any depression in a marine environment where sediments accumulate over time is known as a sediment trap. The null point theory explains how sediment deposition undergoes a hydrodynamic sorting process within the marine environment, leading to a seaward thinning of sediment grain size. Environmental issues. Erosion and agricultural sediment delivery to rivers, one cause of high sediment loads from slash and burn and shifting cultivation of tropical forests. When the ground surface is stripped of vegetation and then seared of all living organisms, the upper soils are vulnerable to both wind and water erosion. In a number of regions of the Earth, entire sectors of a country have become erodible. For example, on the Madagascar High Central Plateau, which constitutes approximately 10% of that country's land area, most of the land area is devegetated, and gullies have eroded into the underlying soil in furrows typically in excess of 50 meters deep and 1 kilometer wide. This siltation results in discoloration of rivers to a dark red-brown color and leads to fish kills. Erosion is also an issue in areas of modern farming, where the removal of native vegetation for the cultivation and harvesting of a single type of crop has left the soil unsupported. Many of these regions are near rivers and drainages. Loss of soil due to erosion removes useful farmland, adds to sediment loads, and can help transport anthropogenic fertilizers into the river system, which leads to eutrophication. Dregs. Sediment in wine, beer, Turkish coffee or other beverages is known as dregs. See also, bar, beach cusps, bioexestocy, bioswale, decantation, deposition, erosion, Kshner equation, particle size, regolith, sand, sediment precipitation, sediment trap, sedimentary depositional environment, settling, surface runoff. References. Prodero, Donald R. Schwab, Fred, Sedimentary Geology, An Introduction to Sedimentary Rocks and Stratigraphy, W. H. Freeman, ISBN A0-7167-2726-9. Siver, Raymond, Sand, New York, Scientific American Library, ISBN A0-7167-5021. Zam, Nichols, Gary, Sedimentology and Stratigraphy, Malden, Massachusetts, Wiley-Blackwell, ISBN A0-632-03578-1. Reading, H.G., Sedimentary Environments, Processes, Physics and Stratigraphy, Cambridge, Massachusetts, Blackwell Science, ISBN A0-632-03627-3A.